Hi, I'm Mr. Fluorine. Here's some history for you. In 1865, an English chemist named John Newlands classified the 56 elements known at that time into 11 groups based on similar physical properties. Siberian-born Russian chemist Dmitry Mendeleev made the first periodic table in 1869. He arranged the elements based on atomic weight and molar mass. Here is a picture of a periodic table from 1891. Notice it doesn't have the group known as noble gases. Many refinements have been made to create the modern-day periodic table.
Now, let's talk about the characteristics of the different periods of the periodic table. The first period contains the alkali metals. These metals are highly reactive and are never found in their elemental form in nature. The second period contains the alkaline earth metals. These elements are soft and silver. They also melt at such high temperatures that they remain solid even in fire. Period 16 is known as the oxygen family. Oxygen and sulfur are nonmetals. The rest are semiconductors. The 17th period contains the halogens. This period is the only one that contains elements in all of the different states of matter at standard temperature and pressure. These elements are highly reactive, and many of them are used in medicine. The last period contains the noble gases. These elements are odorless, colorless, monatomic gases that have a very low chemical reactivity.
Now let's talk about the periodic trends. First is atomic radius. Atomic radii increase moving down the periodic table and decrease moving left to right. This means that lithium is smaller than cesium because each time we step down a column and increases, thus making the electrons further from the nucleus. It also means that I'm smaller than lithium because my core electrons can't shield all my electrons effectively, and thus they're held closer to my nucleus. Now let's talk about ionization energy. This is the minimum amount of energy required to remove an electron from an atom in the gas phase. Ionization energy increases from left to right across the table and decreases as we move from top to bottom. This is because the further away the electron is from the nucleus, the easier it is to remove. Next, we'll talk about electron affinity. This is the energy release when an electron is added to an atom in the gas phase. Electron affinity increases from left to right across a period because it is easier to add a negatively charged electron to an atom as the positive charge on the nucleus increases. Finally, let's talk about electronegativity. This is the tendency of atoms to draw electrons towards themselves. Electronegativity increases from top to bottom and from left to right. I happen to be the most electronegative element. Look how I can steal this electron. Thanks for joining me to learn about the periodic table and periodic trends.